Hello and welcome to your technique video for the determination of Ka from measurements of pH lab. Let's talk safety and disposal really quickly. You must wear your goggles whenever chemicals are out in the lab. If small volumes of the acid or base solutions come in contact with your skin, you can flush the area with water. Let your TA know if there's a large spill. All of the solutions used today can be poured down the sink with water. Today, you will use your new skill, taking pH measurements with a pH meter, with a skill that you practiced a lot last semester, titration. Calibrate your pH meter just like you did last week. Once it is ready, you can begin exercise 1. During this exercise, you will be practicing your technique with a known acid before you try working with the unknown acid in exercise 2. You'll add 20 to 30 milliliters of acetic acid to an Erlenmeyer flask, then dilute it to a total volume of about 40 milliliters. Add a few drops of phenolphthalein to the flask. Prime your burette, make sure your stopcock is in the horizontal position, then fill it up with the sodium hydroxide stock solution to about 1 to 5 milliliters from the start of the graduations. You may find it helpful to lower the burette off the side of the lab bench like this, so that you do not have to reach to pour the sodium hydroxide in. Allow some of the sodium hydroxide to flow through the tip and make sure to tap out any bubbles. Before you start the titration, set up a quick data table. You will record the volume in the burette each time that you take a pH measurement, so you can make a chart like this. Record the initial volume in the burette and the pH of the acetic acid solution, then begin titrating. If you look at the titration curve for a weak acid being titrated with a strong base, you can see that the pH increases steadily until the equivalence point, where it changes rapidly. Once you see that you are nearing the equivalence point, you should take pH measurements along much smaller volume increments. Titrate to the endpoint. It should be a very faint pink. If you're not sure if you have reached it, you can place the flask on a white piece of paper and compare it to a beaker of water to decide if you're seeing any pink. After measuring the pH at the endpoint, go a little further so that you can get data for the entire curve. Once you have determined the Ka from your pH measurements, compare this to the accepted value of 1.8 times 10 to the negative fifth. If it is in the same order of magnitude, meaning something times 10 to the negative fifth, then your technique produces accurate enough results to try to find the Ka of the unknown acid solution in exercise 2. Dissolve the unknown monoprotic acid in about 40 milliliters of water. Add the sodium hydroxide and titrate to the endpoint as you measure the pH. You should reach the endpoint after adding 30 to 40 milliliters of the titrant, sodium hydroxide. If you reach it in less than 30 milliliters, try again with more solid. If it takes more than 50 milliliters to reach the endpoint, you should try again with less solid. Once you find an amount that works, repeat the procedure for a total of 3 trials so that you can calculate an average and standard deviation for your results. That's all for this week, and I'll see you next week.